coming. We're going to be talking to you today about certificate revocation. It sounds kind of boring to a lot of people, but it's actually very interesting, so I'm glad you all came out to listen to us talk about it. We do want to encourage you to ask questions throughout, so don't be shy. If you have a question or comment, please interrupt it at any time. So before I get into certificate revocation on the web, and particularly OCSP stapling, which is what we're going to be talking about in depth today, I want to kind of set the stage here by introducing Sally, the server operator. And you may be a server operator, you may be the owner of a website, you may have things that keep you up at night that you worry about at 3 a.m. What Sally, the server operator, worries about is ways that attackers could break into her server. So she might have some out-of-date software that she's running somewhere on her infrastructure, something like a CMS that might have, say, an RCE vulnerability, which has been known to happen. And if she has some out-of-date software like this that's vulnerable, then an attacker who finds and exploits this vulnerability, even if just for a few minutes, could walk away with, say, Sally's TLS private key. And that's basically the keys to the kingdom. If the attacker gets Sally's TLS private key, the attacker can impersonate Sally's site, and basically all her users and user data are compromised. It's pretty much game over. TLS private key is, really what an attacker wants to get. Or Sally might have nightmares about certificate authorities screwing up. So in this example, I'm highlighting an incident in which Symantec accidentally misissued some certificates during a testing procedure, but I'm not really meaning to pick on Symantec here. There are many, many other CAs who have had similar incidents, and they are not perfect organizations, no one is, and you might wonder, if you're Sally, the server operator, having a nightmare, you might wonder if a CA can accidentally misissue a certificate, maybe an attacker can come along and trick the CA into misissuing a certificate for your site. So this has been known to happen before, and this should be a very, very scary thought if you own a website, because this means that if any certificate authority screws up, they might accidentally issue a certificate for your domain that you didn't authorize, and then there's a certificate floating around out there that can be used to, that an attacker can use to prove that they are your site when they're not. Or there are a variety of misconfigurations or screw-ups that can happen that might be taken advantage of by an attacker to obtain a certificate for your domain. So in this example, sorry, the screenshot's a little small there, but in this example we have a researcher who basically found a DNS misconfiguration on a subdomain of msn.com. And as you can see, they took advantage of this misconfiguration to take over this domain. And once this researcher had gotten to this point, it would have been pretty trivial for them to obtain a certificate for this domain. And so even after MSN had discovered and corrected this misconfiguration, there would still be this certificate floating around out there for this subdomain that had briefly been under the attacker's control. So the point is, when Sally, the server operator, is having her nightmares at night, she's worried about high-value data, like TLS private keys, which can be stolen in really any number of ways. And the question that we're addressing in this talk is, what should Sally do when there's a certificate, she knows there's a certificate floating around out there for her site with a private key known to an attacker? In other words, how does Sally revoke such a certificate so that web browsers no longer accept it as valid? This question of certificate revocation is a pretty fundamental part of the PKI system. It's pretty crucial, but it's kind of like this ugly wart of the web that we don't actually know how to do certificate revocation well on the web. It's a pretty complicated, unsolved question. Today, I'm going to give you some more background about the mess that we have gotten ourselves into, which is certificate revocation on the web. Hopefully I convinced you that it's an important problem, but then I'm going to tell you more about what the current state of the art is, what the solutions that we've tried are, and what went wrong. Then I'm going to tell you about stapling, OCSP stapling, which is a fairly promising solution for certificate revocation that might be able to solve all our problems, but is not particularly well deployed or well studied in the real world. And that's why we need site owners like you to get interested in this question of how to do certificate revocation properly, so that you can figure out what it would take to get your infrastructure to support state-of-the-art revocation. Along those lines, my co-presenter Dev is then going to take over. He's from Dropbox, and he's going to tell you about their experience setting up their infrastructure for revocation and how they used an experimental Chrome feature to kind of evaluate how their revocation setup is doing in the real world. All right, any questions before I jump in here? Okay, so I thought we would get the sad stuff out of the way at the beginning, and I'll tell you about all the stuff that didn't work. But first, I'll give a little bit more background just about TLS and certificates in general, just to make sure the problem is clear here. So in a normal TLS handshake, you have a browser and a server, and the browser wants to send an HTTPS request, an HTTP request over TLS. So it begins by setting up a TLS connection, which is a little bit complicated, but at a bird's eye view here, the client says, hello, I want to speak TLS, provides some parameters that it supports. In this example, it's using a TLS extension called SNI, or server name indicator, to indicate that it wants to connect to the site called example.com. And so the server says, great, I'm example.com. I have a certificate proving that I'm example.com. And it provides that certificate to the client, which then begins the ridiculously complicated procedure of certificate verification. So given this certificate for example.com, the client says, okay, does this have a chain of signatures that chains up to a certificate authority that I trust? Is the certificate valid date-wise? Is it expired or not yet valid? Is the certificate actually for the correct name that I requested? Things like that. So this is kind of skimming over a lot of detail here, but this is kind of an example of what a client might check during the process of certificate verification. So this is the normal good case. This is when everything's going right. But remember that what we're interested in this talk is when an attacker has a private key for a certificate for the domain. So the client is not actually talking to the real example.com. The client is talking to an attacker who has a certificate claiming to be example.com. The problem is that everything to the browser looks exactly the same in this situation. It says, I want to talk to example.com. The attacker provides a certificate proving that it is example.com. And the client goes through certificate verification checks, which come out showing that the attacker is example.com. In this basic TLS setup here, we don't have any way to communicate to the browser that it shouldn't accept this certificate. From the browser's perspective, this attack certificate looks just like a legitimate certificate for example.com. So what we need is a way to communicate to the browser that this certificate should no longer be considered valid, that it has been revoked. And there's quite a bit of history here, things that have been tried that didn't work out so well. The most basic of these attempted approaches is called certificate revocation lists, or CRLs, which is basically exactly what it sounds. The client periodically contacts certificate authorities and asks these certificate authorities for lists of certificates that have been revoked. It downloads these certificate revocation lists, and then when it has a certificate that it's trying to validate, it checks it against these certificate revocation lists to make sure that it hasn't been revoked. So when Sally finds out that there's an attack certificate floating around for her site, she goes to her CA and she says, hey, I want to revoke this certificate. And the CA adds it to its CRL so that clients will download the CRL and not accept that revoked certificate anymore. So as you can probably imagine, this is not the most robust scheme, and it's also quite expensive. And it turns out that in the real world, browsers are just not willing to download these huge CRLs regularly. They're too big, the performance cost is too high, and it's kind of a bad trade-off for browsers because most of the data that they're downloading is not actually going to be relevant to them. It's for certificates they're never going to see. Why do they need to download a list of every revoked certificate in the universe when they're not going to see most of those certificates? So it's a lot of wasted data. There's a variation on this idea of certificate revocation lists, where browser vendors compile lists of revoked certificates that they care about and push those down to their browsers. So for Chrome, this is called CRL sets. Mozilla has one CRL. These are sort of like browser-curated CRLs. So they're supposed to be smaller, only containing, say, high-value certificates or intermediate certificates, things that are sort of more bang for the buck for browsers to download. Oh, sure, yeah. The question was, how does this work for smartphones where you are in a more constrained environment? It basically works the same way. These are not, unfortunately, I should have pulled out some numbers, but I don't have any numbers, but these are designed to be like downloadable by clients like smartphones. So, there are not that many intermediate certificates out there, for example. So if you were to distribute a list of all the revoked intermediate certificates, it actually just wouldn't be that big, and it's tractable for a smartphone. But this doesn't work this doesn't scale. Like if Joe's Pizza Shop has a certificate that they want to revoke, they basically have to go to the browsers and convince the browsers to accept their certificate in these browser-specific revocation lists. So it doesn't really scale well for all the certificates on the internet, and it also doesn't work for non-browser TLS clients. This is a very browser-specific solution. As I was talking about CRLs, an alternative might have occurred to you, which also occurred to some other people who invented the Online Certificate Status Protocol, or OCSP. So with CRLs, you download a whole bunch of revoked certificates, and when the browser is validating a certificate, it checks if that certificate appears in a CRL. But in OCSP, instead do an online check for the particular certificate that we're interested in. So when the browser has a certificate for a site that it's trying to validate, it can go ask the certificate authority, is this particular certificate valid? And the CA will give an answer for that particular certificate. So the browser doesn't have to download all this information about certificates that it doesn't care about. It just has to ask the CA about this one particular certificate that it does care about, because that's the site that the user is trying to connect to right now. I imagine in your mind you're thinking, like, there are so many things wrong with this, and there are. One of them is you've now introduced like a round trip on every handshake. Because before the HTTP request is sent, during connection setup, we have to go in and ask the CA, is this certificate okay? Interestingly, this is actually not as expensive as it used to be. In 2012, 2013, there were studies showing that this introduced hundreds of milliseconds of latency. More recent studies suggest it's more like tens of milliseconds, and that's attributed to better OCSP infrastructure, certificate authorities using CDNs to cache their OCSP responses. So this is no longer the ridiculously, exorbitantly huge performance penalty that it once was, but it still is an extra round trip on every handshake. And even if you're willing to accept this round trip, maybe you don't want the CA to know every website that you visit. Just because a CA has issued a certificate for a site doesn't mean that that CA should learn every time a user goes and visits that site. So there's a pretty big privacy problem here. And finally, there's a reliability problem. It puts the CA in the critical path here, so that if the CA is down, what does the browser do when it can't get an OCSP response? It turns out that CAs go down sometimes, and because of that, browsers have been forced to accept the reality that we can't fail open. Or sorry, no, we have to fail open. We can't fail closed. So, CAs go down, we can't put this extra round trip in the critical path. Browsers have basically agreed, for the most part, upon failing open. If an OCSP request fails, browsers will generally go on and continue the connection just like normal. So these are problems that can potentially be fixed using a modification of OCSP called OCSP stapling. This is pretty promising because we want to tackle these problems of avoiding this round trip, improving reliability, not putting the CA in the critical path, and protecting privacy so that CAs don't learn about every site that a user visits in a browser. In OCSP stapling, we sort of turn things around. Instead of the browser talking to the CA to ask if the certificate is valid, the server does. Every so often, the server goes to the CA and says, can you please give me a signed message stating that my certificate is valid and not revoked? Then the server staples this signed message from the CA when it delivers the certificate. So the browser doesn't have to go and ask the CA in the critical path if the certificate is valid because it has this OCSP response, this signed response from the CA saying that the certificate has not been revoked, stapled in the connection there. This is what we call OCSP stapling. And you can see it has a number of nice properties. We don't have that round trip in the critical path. The server can kind of query periodically and cache the responses that it has. It improves reliability. Did I do these out of order? No. Yeah, okay, we avoid the round trip. It improves reliability in the sense that the CA is no longer in the critical path of what the browser has to talk to on every handshake. Also has a nice property of reducing traffic on the CA because the server kind of queries once and then serves that response to many clients instead of each client querying the CA every time. And it protects privacy because the browser does not contact the CA as part of connection setup. Of course, it doesn't solve any of our problems because it can be trivially bypassed. So if you're an attacker and you have a certificate that you're using to man in the middle a victim, you're just not going to staple an OCSP response. And because browsers don't require stapled OCSP responses, browsers aren't going to care that you didn't staple an OCSP response and you just got away with using a revoked certificate. So basically, this is like a weird thing where if the bad guy chose to report that their certificate was revoked, then the browser would not accept the certificate, but the bad guy's just not going to choose to accept that the certificate's revoked. What we really want is a way to tell the browser that this certificate should not be allowed unless it comes with a fresh stapled OCSP response. And that's basically what must staple is. It's a flag in a certificate saying that the certificate must be provided alongside a stapled OCSP response and should not be accepted as valid otherwise. So if an attacker comes along and recovers the private key for a must staple certificate, they're not going to be able to actually put that to use unless they can also provide a proof that the certificate hasn't been revoked. You may have also heard of must staple as the TLS feature extension. These are both kind of jargony terms, but I'm just throwing that out there in case you heard of it as one or the other. It's also conceptually similar to a short-lived certificate. And I'm not going to talk too much about short-lived certificates. I'll kind of leave this as a thought exercise. But if you have a certificate that is only valid for a week, and every week you renew your certificates, versus a must staple certificate where your OCSP responses, the certificate itself might be longer lived, but the OCSP responses are only valid for a week or less. Those actually have similar properties. They also have somewhat similar operational and deployment challenges. So must staple is supported by Firefox today, and you can go to Let's Encrypt and get a must staple certificate today. So you may be wondering, why are we all not rushing out to buy must staple, or request must staple certificates right now? And why are all browsers, like Chrome, not rushing out to implement must staple right now? The answer can be summed up in this scary. This is Chrome's certificate error page. This is what happens when we encounter an error on certificate verification, and in particular, this is what happens if a site is using a must staple certificate but screws up and does not deliver a valid stapled OCSP response. We think that if everyone were to go implement and turn on must staple today, users would see a lot of this. And we really don't like showing these in Chrome. It's a bad UX. You know, the user just wants to do what they want to do, look at their cat videos or whatever. They're instead seeing this. Most users don't know what this means. They're mostly looking for the, like, okay, let me just do what I want to do button. So it trains users to click through. The more of these we show, the more users get trained that these are just sort of weird errors they see sometimes and they just have to click through them. And that ends up harming the ecosystem in the long run, because when users see these, they should know that this means there's something really fishy going on. So we don't want to go implement must staple right away because we think that would cause a lot of this. And Dev's going to tell you a little bit more about why we think that. In short, it's actually pretty hard to deploy OCSP stapling reliably today. It's also, in addition to being kind of difficult to deploy properly, it's also kind of difficult to know whether you've done it right. You know, how do you really know, if you turn on OCSP stapling in your server, how do you know that you're actually reliably delivering fresh, valid OCSP staples on every connection? How do you know that you're not causing a bunch of errors? And how do you know that clients or networks are actually allowing those to be validated properly? And again, Dev will go into a little bit more detail about what I mean here. But this difficulty of measuring OCSP stapling is why in Chrome we introduced this experimental feature called expect staple. Instead of must staple, it's like expect staple. We're not going to require that you have a stapled OCSP response, but we really expect you to. And it's this experimental feature where you can opt in on this baked-in list of sites in Chrome. And once you've opted in your site, we do basically a report-only version of must staple. So if we connect to your site, and your site is opted in, and that connection doesn't come along with a valid OCSP response stapled to it, then Chrome will send a report to your server or to a location of your choosing, indicating that there was a problem. So it's sort of like a trial run version of must staple. We won't actually fail connections if you aren't delivering OCSP responses properly, but we will send you a report so that you learn about failures in your infrastructure. Okay, so with that, Dev is going to now give you some background about how Dropbox has been using OCSP stapling and expect staple.
All right, hi. I'm Dev. Thanks, Emily. That was great. Now I'm all nervous because I'm not that good a speaker. But how many people work in AppSec here? All right, so you all know, you can empathize. So everything she said was the theory. As we all know, the world is horrible. Everything's terrible. So we're going to talk about what we noticed trying to use this. All right, so out of the box, OCSP stapling support in either your Nginx or Apache install doesn't really work very well. First issue when we started looking at this was OCSP responses are fetched lazily after startup. So if you set up Nginx to use OCSP stapled OCSP responses, it can't actually staple OCSP responses in the first request. When you make the first request, it will go and ask the CA, hey, give me the OCSP response to staple, which you can imagine is not really great, especially at our scale where we have lots and lots of Nginxes restarting and moving around all the time. So this sucks. The other thing is, if the responses expire, Nginx doesn't refetch them in time. Like OCSP responses are only valid for a week. Nginx doesn't remember to refetch them in time. There are a lot of other bugs in similar servers. Even CAs actually have bugs. Let's Encrypt, this is a bug in Let's Encrypt that the Let's Encrypt developer, to their credit, filed, saying that the current OCSP response generation strategy is not good for actually deploying OCSP stapling because way too often the responses would just fail to be generated. So, for something like Dropbox, this is not great. You want something robust and reliable. right? Like we want to be robust against CA or servers, the certificate authority servers being down. Like, we use Digicert is great, but Dropbox's uptime is way higher than Digicert's uptime. Like Facebook's uptime way higher than Digicert's uptime. Like this is not, we can't rely on the CA's uptime. We also don't want to DOS the CA by just like repeatedly asking it for OCSP responses. This is actually another risk that has appeared in the past. And as I'll talk about, we also want to, if the CA is making some mistake, right? Like, I'm not making this up. Literally during development, we try to ask the CA, one CA in particular, like, hey, can you give us the OCSP response? And the OCSP response we got back was for some completely unrelated domain. Which, if you're writing code, you should plan for that. Write those if conditions around it. And start alerting if like we're not getting a new OCSP response in time. So here's the architecture of what we ended up doing at Dropbox. We wrote a new service for OCSP's response fetching that just continuously talks every X minutes to the certificate authority and fetches the OCSP response and checks whether the OCSP response is valid, is for the right website, and all these other checks that we want to do, and then commits it to a secret service. Nginx talks to the secret service every time it reloads and uses the newly fetched correct OCSP response. And so you're able to tell Nginx, hey, use the OCSP response that I've put it in this file. And it loads, like similar to how it will load the SSL search from a secret service, it also loads the OCSP response from a secret service. One quick side point, this sort of service where Nginx or your Apache or something is able to reload secrets is pretty useful in general. There's a paper a few months back about how we need to rotate session ticket encryption keys. Creating this service allows you to rotate session ticket encryption keys also, or allows you to rotate DH params. There was a paper like a year or 2 years back where DH params no one rotates, and that's fine. So being able to do all these things, this service where you can reload secrets in Nginx is very valuable. So we didn't actually create this service just for OCSP. We had many users for it for security. All right, so I was thinking about showing the code, but that wasn't as fun as I think comments. As we all know, comments and code are more fun. so we're going to go through the code via comments. Hopefully this works out. I haven't done this before, so, but feel free to ask questions. All right, so. All right, this is too small then. Yeah, so the first thing it does is create a temp file to write the OCSP response. The reason we want to do this is because we often get invalid responses. And so we want to check and ignore these invalid responses. So first create a temp file to fetch the OCSP response. Then we fetch, but don't during the fetch verify the OCSP response. Because the OpenSSL OCSP command will return non-zero even upon success. So you can't really trust the response of the OpenSSL OCSP command. It also, like during testing and working with this, it looks like the OpenSSL OCSP command is very iffy about the order of arguments. So after a lot of work, we figured out the exact order of arguments for these 10 arguments. And we have a gigantic command saying don't touch the order. Or if you do, don't. Make sure you test it properly. And so we learned that separately, if we call the OpenSSL OCSP verify command, it always exits with return status 0, regardless of whether the response was valid or not. So what we ended up doing was grepping the output for the word OK, which is not the most robust thing, but as far as we can tell, everyone does this. Like there's no other option. So now hopefully this journey in comments is convincing you why we need something like expect stable and not must stable. Like I can't go to my infrastructure team being like, this solid piece of code we're going to turn on must stable. so expect stable is really important here. Does that make sense? We can share the code if people are interested, but it's actually very simple code. Just be aware of all these gotchas like OpenSSL and be very cautious. That's really the main high-level comment, right? As far as I can tell, this is well known, mailing lists and I mean, it will break our script now, so we should, sorry. But it looked like this was expected behavior, so I don't know. Okay, so we deployed this, and now what was our experience like deploying it on www.dropbox.com? So Dropbox deployed OCSP stapling back in February. This was before expect staple discussions with Emily. But I would encourage everyone to deploy OCSP stapling because it's just a big performance win. Firefox, in our case, was fetching, doing that extra round trip with our servers, with the CA servers, for our anytime it did a certificate handshake with Dropbox. And just OCSP stapling kills that extra round trip. So it's actually a good performance win, turning it on, which is also a good argument to use with other engineers inside the company on why we want to deploy OCSP stapling. After we turned this on, surprisingly, our monitoring did not indicate actually that many failures fetching OCSP responses. We actually saw a lot when we were working on this code, but once we turned this on, like over the last year, we haven't seen that many errors. It might be that, DigiCert, our CA, has really good uptime, and as Emily mentioned, there has been a lot of work on improving these OCSP responders. And another theory I have, this might be completely wrong, is the day we deployed OCSP stapling, all these Firefox browsers that were hitting DigiCert asking, hey, give me an OCSP response, stopped. Like all these clients distributed all over the world who used to ask DigiCert's OCSP responder for an OCSP response stopped because they had the stapled response that we were sending them. So I think that also affected the uptime and the reliability of the DigiCert Dropbox OCSP responder. All right. Chrome preloaded, rolled out this expect staple feature and preloaded Dropbox.com in Chrome 54. And Chrome 54 went stable in mid-October. Usually takes a week for the world to update. And we started collecting data. We started getting these reports, and most of the data that I'll be talking about is from the month of November. If you do get into this, as Emily mentioned, we're hoping we'll convince you to start using this also. If you do get loaded into the expect staple list in Chrome, one mild issue in 54 or 55, I think, I don't know whether this was fixed, is that Chrome didn't send a content type JSON header, and the default, pretty much any web server's default like give me body function call, in our case it was like response.body, request.body, would return an empty string because there was no content type. So you had to do like request.get bytes or something. But we actually just ended up rewriting an Nginx to like force content type of application JSON. So that works. Alright, are you all with me before we dive into the data? Alright, so the JSON report, the expect stable report from Chrome has a bunch of fields. The first field is date time. This is the time that the client was on. Like this is the, if the client is connecting on, the browser is connecting on like 13th November, blah, 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 second hour, it will be that time. The response status is what Chrome thought of the OCSP response. It might be like, hey, I expected a stapled OCSP response, but there was none. Or error response, that the return stapled response was actually wrong, like it was saying it was not valid for this connection. Or invalid date, which says that the OCSP response is only valid for a week and the current it was older or from the future, which is another type of error. And there's a bunch of other errors. You can see the spec for more details. And the report also includes the actual OCSP response. So, when the response status is not missing, the actual OCSP response that Chrome used for making these decisions is included in the report. Alright, so how do you do the data analysis? You run this command, OpenSSL OCSP text inside with the OCSP response you got in the JSON report. It will give you this output, OCSP response status successful. This is the basic OCSP response. And the field I want to point out is like this update was October 12th, next update October 19th. So this means the OCSP response was valid from October 12th to October 19th. Connecting on October 15th, this will be considered a valid OCSP stapled response. If you're connecting on October 25, this won't be a valid OCSP response. Does that make sense? Alright, so now the data collection is simple, right? Like we look at this update, next update fields and say, how does this compare to the date time field? And that will tell us if it's an invalid date, hey, this is why it was invalid, or how much off it was from the valid date. So when we started doing this analysis, the vast majority of errors that we saw are missing. And this is because of, we believe, TLS proxies, antiviruses, or all these like TLS proxies that people have installed. where they have a local root, and so they see the they terminate the Dropbox SSL connection at the proxy, and then have a TLS connection with the user's browser. But since the user's browser is running Chrome, it has the expect staple preload for Dropbox.com, and it says, I don't see a OCSP response. So we get an error saying missing. But we know this is TLS proxies because the cert chain is missing in the uploaded report that basically tells us this is a local root. So we are pretty confident that this is TLS proxies. And this won't actually be a problem in the real world if we turn on must-stable, because Chrome and any browser will just ignore OCSP must-stable if it's a local TLS proxies certificate. Nearly all the remaining errors were invalid, that the stapled OCSP response is not valid for the current client's time. As I showed earlier with the example, OCSP responses are typically valid for a week, let's say November 5 to November 12. And anything after November, like if your current time is after November 12, you will say invalid date. Or if your current time is before November 5, you will again say invalid date. And so we could look at the data that we are seeing. We could see the time the Chrome included in the report, compare it with the data in the OCSP response, and say how much off was it. And so we started doing that. Yeah. With the what? Yeah, so it's valid for a week. Yeah, so tomorrow. Yeah, so the question was, are we worried about any problems due to internationalization, or like, we are in America, someone is like 24 hours ahead and like New Zealand maybe? I guess that's what also you're asking. The OCSP responses are valid for a week and are usually backdated. Like they aren't, we don't start getting the new responses as soon as they're issued. We get them like a day later or 2 days later, I think. So they're usually fine. But it's, yeah, hold on to that thought because there are related problems. So we looked at all the errors, and I'm only showing data from the 5th percentile to the 95th percentile because like there were some clients that had like 3-year-old clocks, and then your host, right? Like there's really nothing. There's no HSTS, there's no HTTP here. Let's just forget about it. So like the 5th to 95th percentile is like vast majority of the errors that you're seeing. So that's the main data I want to focus on. And so what that means is that, looking at this graph, you can see that less than 5% of errors were with clients who had clocks more than 7 days behind, because the x-axis is -7 here. And less than 5% of errors were clients with clocks who are more than 1 day ahead. I want to point out this is 1 day here and -7 here. And so 5th to 95th percentile. Right? Does the graph make sense? -7 to 1 day. All right. Same CDS, but now let's go through the actual graph that we saw. So 95% of the remaining errors, client clock is maximum behind a week by a week. Like the client clock is actually behind the valid OCSP response. So the client is seeing an OCSP response from the future. 50%, if you go plus or minus 1 day of validity, 50% of errors are covered. And 75% of the errors are covered in the like 3 days behind, 1 day future scenario. So like vast majority of errors are covered within like just off by a few days here and there. So this is a common problem. TLS has always had this problem. Client clocks being wrong is an old problem in TLS. And this data that we're seeing matches what previous studies have seen around like TLS, TLS timestamp and like verifying TLS certificates and errors with those. One thing I want to point out, as Emily said, right, like week-long short-lived certificates is very similar conceptually to OCSP statement. What expect stable let us do is measure, if we did week-long certificates, what sort of errors would our clients see, and without actually impacting any of our users in terms of downtime. So we know that if we tomorrow try to switch to week-long certificates, so many users will just like hit errors all the time because their client clocks are not actually within the like acceptable bound of a week. And in our case, we have HSTS turned on with include subdomain, so you can't bypass the warning either. So that would really suck. Yeah, Scott. So this is happening at the TLS layer, so it's kind of hard to figure out which is the user, like what percentage of users and what percentage of connections, because it's only Chrome. Like, yeah, so it happens at a completely different layer. We know the pure numbers and we can make a guess. Unfortunately, I haven't confirmed with all the right people whether I can share those numbers, so sorry. Yeah, I was sorry. So this is a known problem. Adam Langley and others have proposed this protocol called runtime, which is this distributed consensus algorithm, so that all browsers can decide this is the correct time. Even if the client clock says it's sometime something else, let's use this for SSL verification. Like, users will change their client clocks to get Candy Crush working. This is not, like, I'm not even making this up. This is literally a known phenomenon. So like that should not break OCSP stapling, and that should not hold back short-lived TLS certificates. So what are the solutions? Browsers could enforce a correct time. It's already a problem because insecure time services allow bypassing HSTS, HTTP, and all these mitigations. And browsers are working on this, the Rough Time project by Google. You can Google for that if you're interested in learning more. I personally, because I like to have fun, think that is it really a problem if a certificate, like we have an OCSP response saying that this certificate is valid from the future. Like if a CA has come in from the future and told us this private keys or certificate is still valid, is it valid now also, right? From the past I can understand being a problem, but like, hey, today is 24th Jan and the CA tells me like this certificate is valid from Feb 1 to Feb 8, I should probably accept it for today also, is my thing. This is an ugly hack. I, first one to acknowledge this is an ugly hack. But vast majority of errors are due to client clocks being behind the OCSP response. Maybe like people have batteries that are running out, or like their game is going to expire, so they move the clock back. I don't know. But like fixing those errors and helping us deploy OCSP would be really cool. There were a few other errors that I wanted to quickly call out. We saw a bunch of errors where it was a local root, it was a TLS proxy, but the OCSP response status was invalid. So if you're running, so what this meant was the stapled OCSP response was not valid, and it was a local root. So if you know someone or you are running a TLS proxy, your man in the building TLS, please also throw away the OCSP response that we are stapling. Please don't continue passing it along. It quite unnecessarily screws up our measurements. Finally, before we end, quick call to action. You all, are secure websites, are probably intimately aware with the TLS configurations of all the websites you run. We would love your help with deploying OCSP must staple, deploying short-lived certificates, and that needs a lot more data. So consider implementing OCSP stapling in your servers. It's a performance win, so it's a pretty convincing argument to make because it helps performance also in addition to long-term security improvement. And enroll in the AppSec staple preload list. Also, like finally, because Scott is here and I'm going to call him out right now, something like reporturi.io supporting AppSec staple reports would be awesome because then no one has to rewrite this again and again. That would be great. And as Emily said, right, like right now it's this dirty word. Revocation is a dirty word, and we don't talk about it, but like that can't go on forever. We need to start talking about as a community, what are we going to do? And so like collecting this data will be massively helpful. And Dropbox paid for my flight here, and Google paid for Emily's flight here and hotel, and same for me. So yeah, we're all Dropbox is hiring in our product security team. Google's hiring, Google Chrome's hiring. If you're wondering how I'm advertising for both, if you go work for Chrome security, you'll probably help Dropbox security also. Just don't go work for Google Drive. That's all I ask. And that's it. Yeah, cool. Thanks a lot for listening. Thank you. Yeah.
Reports that browsers send. What is in a report? What data is there?
It's the date time, the actual response it saw, and what was the error at a high level. It also has the certificate chain and stuff, but those are the main high level things. Yeah. Sorry, you had a question? Just shout it out. I can repeat it. Yeah.
Is there any revocation for the OCSP signature itself? So it is valid for 7 days. If it's not revoked, and someone gets that and
I don't think. I think this is like the turtles all the way down, sort of like at some point, like some amount of risk we accept. Yeah, unfortunately, but yeah, I think. But the window there is short, right? Like it's like 3 days, a week at the most. like on average, so since it's totally, the whole thing is valid for a week, we are talking about at most, like on average, a 3-4 day window, right? So hopefully, that's good. It's better than 2 years, I think. It's like.
Did you say the code was open now for your, all the OpenSSL commands are really hacky and horrible, and I have an OCSP cache primer written in Bash.
I'm happy to share it with you. Just send me a mail. Open sourcing it's not really very interesting because it's very tied to the secret. Like the hard part there is the secret service and getting Nginx to reload secrets and stuff, which is just like how we do infrastructure. But the actual OCS, it's just a bunch of commands, so I can share it. It's not a big deal.
You mentioned actually this Nginx and secret service. Could you describe at a high level what you guys do to get the correct secrets into Nginx? If you know.
So Nginx just has a command for just reloading the config. And so if you send that signal to Nginx, if the file with the secrets has been updated, it will just reload that file. So you just have to do it with the appropriate times with the right monitoring and after you have changed the secrets and stuff. So it's actually not hard, it's just a bunch of like duct taping and like pipe work that you have to do. But it's so it's like Nginx-s reload, and that's it. Like who knows? Yeah, that like Sorry, yeah, so you do know when a certificate has been misissued because the cert transparency log will show. So like the service crt.sh will, if you want to, but there are services like crt.sh, Facebook has a service that will tell you, I don't know, Jen, do you know the name of that service? Okay, yeah, so developers.facebook.com/tools/cd will tell you, you can tell like, hey, I'm the owner for this domain, tell me whenever a new certificate is issued, and then you can know if someone misissued it. Whether you got hacked and someone stole your existing private key, that there isn't like, how do you know whether you've been hacked, right? Like that's just I would recommend moving your private key also to some hardware backed like lockdown service if possible. But yeah, that's much harder. You can't really know. But usually you know, right? Like people do disclose breaches all the time.
Actually, I had a question.
Yeah.
I have Mike. I only mentioned the dependencies and not showing too many fail pages, and that's why it's not implemented. And it's very complex, right? It's chicken egg. A lot of things need to come together. The CA needs to provide the information for the stapling. The browser needs to support it. What's the order of things? All the CAs need to offer the service? Do all the browsers support the reporting? Do all the web servers need to enable it? Does it all need to come at once, or is there a certain order in which this needs to happen?
I'm a never-ending optimist in security, so I mean it has to happen step by step, right? I think our presentation clearly indicates our bias towards what's the order. I think websites deploy OCSP stapling, we turn on expect staples, see what the errors are, we fix those errors, and at some point we feel comfortable turning on a staple. And then maybe you start with Chrome, then we like drop off every Chrome client so we could turn it on there, and then slowly. But like things happen slowly, but they do happen. Like now, HSPS, CSP, HTTP is a thing in the conference, and so many people have it. 3 years ago, I was here, and like CSP was the black box, no one knew about. So things like we make progress. It's not bad.
Good final word. Sorry, we have to wrap up.
I mean, we're happy to take questions. You can find us at school. But yeah, thank you. After the meeting. Thanks a lot. Thank you.